So here's the graph, and we are supposed to find, for part D, find all values of x on the open interval -3 to 4 at which g has a relative maximum. Okay, so remember that this is g right here, right, that area function. And if you take the derivative of g, you will get f of x, okay? So one really important thing to understand here is that g prime of x is equal to f of x. It kind of looks like a capital F. There we go. Is equal to f of x, okay? So if I want to know where there is a relative maximum, then I need to consider that this graph is the derivative. And the derivative will tell me where there are maximums if the derivative is 0 and it changes from, let's think about this. So a maximum would look like this. So it changes from increasing to decreasing. In other words, the derivative would change from positive to negative. Okay? So let's take a look here. It's positive there, and then it switches to negative here. Okay, so that is going to be a maximum at x equals 1. All right, and then here there's a 0 of the derivative, but it changes from negative to positive, which means it's changing from decreasing to increasing, which would indicate a minimum. Okay. The endpoints here, this endpoint would be, is obviously it's a 0, and it starts off at 0, but then it goes positive, which means it starts off like this, and then the graph of f of x starts off going up. And so this would be a local minimum here. It would not be a local maximum at the end point.
Wait, is this another graph that's like the tangent? No, not the tangent. Like the derivative of some arbitrary function?
Yes.
And then the questions that it's asking is about the original function?
Right. Yes, most of the time, yeah. Yeah. So the only local maximum is this. All right, cool. So then you had a question on part E as well, right? So part E says, write an equation for the tangent line of the graph of g at x equals -1. So let's clear out all this. Well, we do need to remember that g prime is f here, okay? And actually, we probably don't need the picture anymore. Well, yeah, I guess we don't need the picture. All right, so we are trying to find the equation of the tangent line of g at x equals 1. Okay, so I need two things for the equation of a tangent line. I need the a point on the line, and I need the slope, right? If I have both those things, then I win. So if I can find what g of 1 is, then I can get the point. G of 1 you're supposed to find, hold on, this is all supposed to be -1. There we go, sorry. G of -1 you were supposed to find in part C, and you get that it's equal to pi, although given that there's a test question just like this, it might be worth kind of just figuring it out right now. So G of -1 is going to be the integral from 1 to -1 of f of t dt. All right, and so first problem is we have the upper and lower bounds have to be switched and then made negative. Hey, what's there we go. Okay, so I'm going to change the bounds and make it negative, so it's going to be -1 to 1 of f of t dt. And so then this is going to be the area underneath of the curve from -1 to 1 of the function f. And so if you look at the curve here, from -1 to 1, that's a quarter of a circle, right? And then whatever area you find there, you're going to have to take the negative of it, because that negative out in front of everything. So you end up with, I believe, -pi. No. Okay, so that tells us that the point -1, -pi is on the curve, right? Questions?
You also found that information in C, I think.
Yes, we did. I just wanted to go through it just because there's a test question like it, and so.
Wait a minute.
Yes, you already had that information, or you should have if you did C right. That's right.
Okay.
All right, so now we need to figure out what the slope at -1 is. That means we need g prime at -1, and we already said that g prime of x is equal to f of x, so that means we want f of -1. So I'm going to go to the graph again. I'm going to look at f of -1. I'm going to see that it's at 2, so I can write that g prime of -1 is equal to 2. Okay, so here's my slope. Here's my x1, y1. And so I can get the equation of the tangent line. Y equals 2 times x minus a -1, so plus 1, minus pi. And then just finish it out. Y equals 2x plus 2 minus pi, and that's as simple as it gets. Okay, so part G says find the range of G. So the range means you need to look at basically the absolute minimum to the absolute maximum. So that means you're going to have to check endpoints and extrema, right? So we already identified a couple of extrema. So there's got to be an extrema here and an extrema here. We figured out that this was a local maximum. So if we kind of track our maximums, they occur at x equals 1, and g of 1 was equal to 0. Okay, so I'm going to put y values here. I hope that doesn't make anyone mad. So 0 is a max, because that's what g of 1 is. And then where are other potentials? So this is a minimum right here at 3, right? So there's a min right there. So we'll go figure that one out. Let's look for the absolute maximum first. This is an endpoint, so we will check the value of g of -3. And then we need to check the value of g of 4 as well. So we need to know what those are. G of 4. I actually don't know if all of this is getting recorded. We'll hope it will. Hope that it is. All right, g of -3. So did we figure that one out in a previous problem? No, we didn't. Okay, g of -3 is going to be that semicircle there, and we figured this out.
Mr. Kressel is not getting recorded.
Can you guys see it?
Yeah.
All right. So g of -3 is this semicircle right here. And so that's just going to be 1/2 times pi times, I really thought I wrote that down. I wish I didn't write it down yesterday. So it's 1/2 pi r squared. And the radius is 2. So it's going to be 2 pi. Okay, so g of 3 is 2 pi. Whoa. Okay, so 2 pi. G of 4, we've got to go check that. G of 4 is the integral from 1 to 4. All right, and you can see pretty easily that that is not going to be, so that's a potential maximum, or I guess a potential minimum too, but g of 4 is going to be a negative number. So because g of 4 is going to have more negative than positive, okay, so that one can't be a max, and it's not going to be as low as, this should be negative, shouldn't it, guys? Okay, so it should be negative because when you take and when you integrate, so like g of -3 is going to equal the integral from from 1 to -3, right? And so when you actually integrate, you're going to have to change the bounds, so you'll get a negative there. Okay, so this is going to be our minimum, because if you look, this negative area is not going to be greater than -2. So here we have our minimum, and here's our maximum. So to sum up in a way that is not scrawled with a pen on, or a mouse cursor, sum up, our absolute maximum is at 2 pi. Our absolute maximum is at 0, excuse me, which was g of 1. Our absolute min was at g of -3. which is equal to negative 2 pi. So our range is from negative 2 pi to 0. Okay, so there was a lot that went into that one, sorry. Okay, but for the test, you just need to know how, the really important thing is that you know that g of x, or g prime of x is equal to f of x. Okay, questions?